Don't forget to subscribe and press the bell icon to never miss a video from testbook.com.
Hello friends, a very good afternoon to all of you. So guys, बहुत ही important दिन है आज का. We are going to continue with the discussion of Eulerian and Lagrangian approach. So I think 2-3 days have passed by since we had our last session. So actually heat transfer and fluid mechanics session got exchanged. And also in between there was a Sunday. So on Sunday I'm not taking any classes because actually on Sunday I have some other class. So already there is a class in the morning and there is a class in the night. So my classes will run only for 6 days a week. ठीक है ना? So Monday, Wednesday, Friday, that would be heat transfer, and Tuesday, Thursday, Saturday, that would be fluid mechanics. So it has been very important week for fluid mechanics. So as I told yesterday also, Intel has come out with its new processors. So whenever a new processor is formed, so there is a role of fluid mechanics in it, heat transfer in it, because a new processor means a new type of cooling system, ठीक है ना, advanced cooling system that would keep the temperature of processor down and maintain its speed. Obviously उसमें जब नया प्रोसेसर आता है तो उसमें कंपटीशन स्पीड वगैरह भी इंपॉर्टेंट होती है, मगर फ्लूइड मैकेनिक्स और हीट ट्रांसफर का भी उतना ही रोल है, उनकी इन सिस्टम्स की कूलिंग का भी उतना ही रोल है. Then cyclone Tokte came, है ना? So yesterday cyclone Tokte, it achieved a speed of around 100 knots. So 100 knots is like 185 kilometers per hour. And they were saying that at the eye, the clouds had a temperature of minus 90 degrees Celsius. So this is something I read on meteorological department. समझ रहे हो आप? minus 90 degrees Celsius. तो eye में था. I means the very center point, which was not on the land, by the way. ठीक है? When it was in the sea, and obviously up in the sky. ठीक है? So as I always say, how a cyclone is generated, where it will be generated, when it will be generated, how it is going to move, where it will make landfall, once it makes landfall, how it will dissipate. So इसमें fluid mechanics का बहुत बड़ा रोल है. Till now, this mathematics is, actually most of the mathematics of fluid mechanics is not made out. So from experiments, from observations, from past history, they predict the data. Meteorological department predicts the data. ठीक है? Anyways, I think without wasting any time, we should quickly start. है ना? Without wasting any time, we should quickly start, because today we have 1.5 hours only. And we have some good number of questions to be discussed. काफी सारे क्वेश्चन डिस्कस करना है, तो बिल्कुल ध्यान से जो है ना पढ़ना चालू करते हैं. लास्ट टाइम मैं थोड़ा सा डिस्ट्रैक्ट हो गया था while teaching because of someone's comment, मतलब not our students comment, किसी और के उससे. तो ठीक है, कोई बात नहीं, आज उसको improve करते हैं. So guys, last time we started with the Lagrangian versus Eulerian approach, है ना? So when you say Lagrangian approach or Eulerian approach, actually what it means is that for any dynamic system, there are two possible ways of studying the system. ठीक है? So any dynamic system means a system where we can see some changes, a system where the bodies or the particles are moving, deforming, है ना? So that is a dynamic system. So if you are explaining the system by Lagrangian approach, first of all, what you will do? You will identify all the particles in the system. First of all, you have to identify all the particles in the system. ठीक है? So say for example, there is a fluid mass. So a fluid mass is made of very large number of molecules. So every molecule has his or her own behavior, है ना? So these molecules will become the particles. So in Lagrangian approach, actually the standard particle is a molecule. Lagrangian approach में जो standard particle होता है वो molecule होता है, और जो मैं आपको definition देने वाला हूँ particle की, that will be different. That will be according to Eulerian approach. So according to Eulerian approach, a particle is a group of molecules. तो थोड़ा सा डिफरेंस है, ठीक है, बट हमें उतना अभी सोचना नहीं है. अभी आप सिर्फ इतना ही बोलोगे Lagrangian approach means first of all identify all the particles in the system, ठीक है, all the particles in the system. Now once you identify all the particles in system, what you will do? You will write down the position of particles as a function of time. So position of particle A, and obviously since the particle is moving, this position of particle will change with the time. Now I hope you remember when we take the derivative of the position, we get the velocity of particle, है ना? And since position is a function of time, so position means x coordinate function of time, y coordinate function of time, z coordinate function of time. I hope you remember. So those people who are watching the videos, if you are watching the previous videos, so last to last class we discussed a question on this. हमने एक क्वेश्चन भी किया था. तो मान लीजिए if the x coordinate of particle is 2t square, so dx by dt, that is u, it will become the x component of velocity of particle, है ना? So this will become 4t, and the derivative of acceleration derivative of velocity du by dt, that will become 4, which is the acceleration of the same particle. So when position is a function of time, velocity can also be a function of time, and acceleration can also be a function of time, right? So what we will have? We will have derivative of position, which will be a function of time. And if you take the derivative of velocity, you will get acceleration of the particle, of the same particle, which can be a function of time. But derivative of velocity means double derivative of position. So I think this we have already learned. And in Lagrangian approach, not only we identify these functions, but we also identify how the density of the same particle will change with the time. Similarly, how the pressure on the same particle will change with the time. So these functions also we write down. So जब भी आप Lagrangian approach की बात करते हैं, first of all you identify the particles and you study each and every particle individually. For every particle you write down these functions. Now question is, sir, suppose there is a pump. So the general representation of pump is that let us suppose there is a sump over here. Sump means the reservoir, groundwater, and we want to lift the groundwater to the top of the building. So we are using a pump. Okay? So this is the inlet of the pump and there will be an outlet of the pump. So this is the general representation of showing a pump, centrifugal pump, like this. Okay? And from the pump we are supplying water to a syntax tank, black color tank at the top of our building. Okay? This is a question. Now suppose exactly at 3 p.m. I need to find out how much power is required by the pump. How much power we should supply to the pump so that water can be lifted to the tank. ठीक है? This is the question. क्या question है? कि exactly 3 बजे मुझे पंप को कितना पावर सप्लाई करना है ताकि मैं पानी को लिफ्ट कर सकूं टैंक तक. So the question is dealing with exactly 3 p.m. Question is dealing with exactly 3 p.m. Okay. So what I will do, first of all, I hope you understand, which you will learn later on also. If you want to find out the power consumed by the pump, you should know pressure at the inlet of the pump and you should know pressure at the outlet of the pump. Once you know these two values, then using Bernoulli's equation, we can find out how much is the power required by the pump. So if I am going through Lagrangian approach, just have a look what I will do. First of all, I will try to find out the particle which crosses the inlet at 3 p.m. Okay? What I will do? I will find out the particle which is crossing the inlet exactly at 3 p.m. So this particle will have some pressure, there will be some pressure on the particle. So first of all, I will identify the particle which is crossing the inlet at 3 p.m. and at 3 p.m. what is the pressure of that particle. ठीक है? तो मैंने क्या किया? मैंने देखा कि कौन सा पार्टिकल इनलेट को क्रॉस कर रहा है 3 p.m. पर और फिर उस पार्टिकल का प्रेशर कितना है 3 p.m. पर. ठीक है. So particle crossing the point at 3 pm and the pressure of particle at 3 pm. This will actually give you pressure of inlet at 3 pm. Correct? This will actually give you pressure at inlet 3 pm. Now similarly, I will also identify the particle which is crossing the outlet at 3 pm. And for that particle, what is the pressure at 3 pm? So this pressure will be the value of pressure at outlet for 3 pm. समझ रहे हैं आप? So like this, I will get the value of pressure at inlet. I will get the value of pressure at outlet, both for 3 pm, and I will get the power production. So what is the approach? What is the approach? You find out the particle crossing the point at the time of concern. Find out the particle crossing the point at the time of concern. So maybe particle A is crossing the point at the time of concern 3 pm. ठीक है? T time instant. And at 3 pm the pressure of the same particle is 1 bar. But at 3 pm, where was the particle? The particle was here. So what is the pressure here at 3 pm? It is 1 bar. So this is how you do it. समझ रहे हैं आप? This is how you do it. You identify the particle crossing the point at the given time instant, and for the given time instant, what is the property value of particle? That will become the property value of the point. Now problem is the pressure at the inlet of the pump and pressure at outlet of the pump, they will not be constant with the time. They might be changing with the time. So power consumption of the pump will also change with the time. Now this analysis you have done for a particular time instant. So you will have to do the analysis for 4 pm also, 5 pm also, 6 pm also, 7 pm also. So you will have to identify that which particles are crossing the point with the time, and when they are crossing the point, what are their pressure values. So this approach actually becomes very complicated. काफी complicated हो जाता है. So what we do, instead of going for Lagrangian approach, we go for Eulerian approach. So hi Adarsh, how are you? Nice to see you after so long. बेटा कैसा चल रहा है सब? काफी दिन से तेरे से कुछ सुना नहीं. तैयारी व्यारी चल रही है आगे की या नहीं चल रही है? तो ये क्या है, मतलब जैसे जो लोग पहले कहीं पे पढ़ चुके हैं, है ना, और ऑब्वियसली अब उनके पास कोई गुंजाइश नहीं है, वो खुद से ही प्रिपरेशन करेंगे, या जो स्टूडेंट्स हैं जिनके पास रिसोर्सेज नहीं है, या जो फर्स्ट ईयर सेकंड ईयर स्टूडेंट्स हैं जो पहले से बेसिक्स बनाना चाहते हैं, तो उनके लिए वी आर एग्जीक्यूटिंग 150 डे कोर्स. सो एवरी डे ऑल द सब्जेक्ट्स आर रनिंग ऑन ऑल्टरनेट डे बेसिस एक्सेप्ट फॉर मैथ्स. मैथ्स डेली होता है मंडे टू फ्राइडे, और एप्टीट्यूड होता है सैटरडे संडे. तो मैथ्स का टाइमिंग है 12 o'clock. ऐसे ही एफएम और हीट ट्रांसफर का टाइमिंग है 2 o'clock. सो 2 to 3:30. सो मंडे वेंसडे फ्राइडे हीट ट्रांसफर, एंड ट्यूसडे थर्सडे सैटरडे फ्लूइड मैकेनिक्स. और उसी तरह टीडी का टाइम है 4 PM. एमडी और टॉम का भी टाइम है 3:30 का, ऑल्टरनेट डे बेसिस पर. तो इस तरह से आप टाइम टेबल चेक कर सकते हो और इन वीडियोस को यूटिलाइज कर सकते हो. And definitely we would also appreciate if you can help us circulate this information. हमने भी information को spread करने में ज्यादा ध्यान दिया नहीं है, ठीक है, तो हमें भी फायदा होगा. तो नहीं, तैयारी नहीं चल रहा है, डू लेट मी नो कि अभी कुछ प्रॉब्लम चल रहा है. अच्छा, तो मेरे से भी बात कर सकते हो अगर किसी भी तरह का प्रॉब्लम है. वी कैन डिस्कस. स्टूडेंट्स कॉल करते हैं, कभी कभी पर्सनल प्रॉब्लम के लिए भी कॉल करते हैं, गाइडेंस के लिए, ठीक है. चलो फिर मैं एक बार ये कंटिन्यू करता हूं, ठीक है. सो एक्चुअली दिस इज अ वेरी Lagrangian अप्रोच, वेरी कॉम्प्लिकेटेड अप्रोच. फर्स्ट ऑफ ऑल यू आइडेंटिफाई हाउ द which particles are crossing the point with the time, and when a particular particle is crossing the point, what is the value of its property. So it becomes a little lengthy. So what we do, instead of going by Lagrangian approach, we go by Eulerian approach, and Eulerian approach is very easy. Eulerian approach is position oriented, location oriented. It is not particle oriented. Here we focus only on locations. So what you do, every property, whether it's pressure, whether it's density, whether it's velocity, every property we describe like this: property at a point x, y, z when the time instant is t. And last time we saw it, how we did this, hai? Last time we saw it, how we did this. Now let us suppose we are talking of velocity. And in velocity, all three components are there. So when I will write velocity as a function of position and time, when I am writing like this, actually I mean the x component of velocity as a function of time, y component of velocity as a function of x, y, z and time, and w component of velocity as a function of x, y, z and time. ठीक है, ये आपका यूलेरियन अप्रोच होता है. Now question is, sir, what is the meaning of this? What is the meaning of this property as a function of x, y, z and time? So it means that you do one thing, you describe the space by a coordinate system. So this is the space where the fluid is moving. तो मैं देख सकता हूं कि कुछ बच्चे वीडियो देख रहे हैं, 3-4 बच्चे वीडियो देख रहे हैं. तो जो लोग भी वीडियो देख रहे हैं वो इन बिटवीन डाउट्स भी पूछ सकते हैं. ठीक है, आई होप आप लोगों ने प्रीवियस वीडियोस देखा है, क्योंकि मैं कंटिन्यूशन में चल रहा हूं. तो अगर प्रीवियस वीडियो देखा होगा तो आज का वीडियो समझ आएगा, प्रीवियस वीडियो नहीं देखा होगा तो आज का वीडियो समझ नहीं आएगा. तो जो लोग बाद में भी वीडियोस देखेंगे उनको मैं सजेस्ट करूंगा आप एक प्रॉपर ऑर्डर फॉलो कीजिए, सारी वीडियोस देखिए, आपको किसी बुक की, किसी और लेक्चर सेशन की जरूरत नहीं पड़ेगी. ठीक है, फिलहाल तो नहीं पड़ेगी. सो व्हाट इज द फिजिकल मीनिंग ऑफ दिस property as a function of position and time? The physical meaning is, this is the space where some fluid is moving. Now this can be the room or this can be the pipe also. Matlab in my room air is moving because of fan. In a pipe the water is moving because of the pump, है ना? So this is the space where some fluid is moving. Now in the space you mark a point. So point will have some coordinates x, y, z. So exactly at time instant t, that is 3 p.m, the value of velocity at the point. So value of velocity at the point is this UVW. So what we have? What is the value of velocity at the point x, y, z when the time is t? What is the value of velocity at the point x, y, z when the time is t? Now please note, point is a position. So even though I say velocity at a point, this does not mean that the point will move. Point will remain at its position only. It is the particle at the point which is moving. सही बात है ना? अगर आप बोल रहे हो velocity at a point, तो पॉइंट तो मूव नहीं करेगा, पॉइंट विल स्टे देयर ओनली, है ना? सो व्हेन यू से वेलोसिटी एट अ पॉइंट, इट मींस द वेलोसिटी ऑफ पार्टिकल एट द पॉइंट. वेलोसिटी ऑफ व्हाट? वेलोसिटी ऑफ पार्टिकल एट द पॉइंट. सो इवन दो वी यूज यूलेरियन अप्रोच फॉर पॉइंट्स, but this doesn't mean that when we say pressure at a point, density at a point, velocity at a point, it is not because of the point. It is not for the point. It is for particle at the point. तो ultimately particle से ही related होता है. And this statement helps us to go from Eulerian approach to Lagrangian approach and Lagrangian approach to Eulerian approach. We have seen one question in the last class related to this, but when the time will move ahead, we will see more questions also. ठीक है, तो चलो फिर आगे बढ़ते हैं. Now question was, why velocity is a function of position? Why velocity is a function of position, or why velocity is a function of time? So I took two examples to show you this. So in both the examples there was a room, and in the room there is a fan and an AC. In the room there is a fan, so the fan is in the middle of the room. Fan is in the middle of the room, and AC is on the maybe left side corner. AC is on the left side corner, okay? And in the first example I said you take a photo. Photo means 9 a.m. You take a photo 9 a.m. in the morning. So in the morning it is comparatively cool. So only the fan is running. What is running? Only fan is running. So right now I'm talking of a photo, particular time instant. I'm talking of a time instant T. Okay? Now for this time instant, if I take a point over here, A point. So at this point, the particle will be moving in this direction with some velocity. And if I take another point B, the particle will be moving in this direction because of the location of the point. है ना? So what is this? This is the velocity at point A and this is the velocity at point B. When? 9 a.m. When? 9 a.m. है ना? So at a given time instant, 2 points can have different velocities. 2 points can have different velocities. Obviously, when I say velocity for a point, I don't mean that the point is moving. Actually, the particle at the point is moving, है ना? But we are describing for points. So what I will say, exactly at 9 a.m., the velocity at 2 different points can be different. So velocity at 2 different positions can be different. So velocity will become a function of position. Velocity will become a function of position. And the difference of velocity between the 2 points, this is called as convective difference. This is called as convective difference. Convective difference. Not in exact terms, but in layman terms. 2 points के बीच में जो velocity का difference आएगा, वो convective difference कहलाएगा. ठीक है? Now, the other part, that was the local change. So, other part, local change. So now what you will do, you will focus only on one point, A point, okay? And for A point, you will make a video from 9 a.m. in the morning, from 9 a.m. in the morning to 2 p.m. in the afternoon. So basically, we are talking from one time instant to the other time instant. So now I am talking of a time period. In the first example, when I write down convective difference, I talk of time instant. In the second example, when I write down local change, I talk of a time period. In the first example, I compare 2 points. But in the second example, I talk of a single point. Now what will happen? Because of the fan, what will happen? At point A, the particle will move in this direction. This is the velocity at the point in 9 a.m. At what time? 9 a.m. But in the afternoon, it was hot. So I switched off the fan and switched on the AC. So because of AC now, the velocity at the same point will be in this direction. So this is the velocity of this is the velocity at point A for 9 a.m. And this is the velocity at point A when the time is 2 p.m. है ना? So I hope you can observe the velocity at a point is changing with time. So velocity can be a function of time. This is called as local change. This is called as local change. So these terms we described last time also, convective difference and local change. So in convective difference, you take a photo. In convective difference, you talk about mid-semester, and during the mid-semester, you compare the performance of 2 people. So in convective difference, you take a photo, and in the photo, you compare the velocity of 2 points. Okay? So that difference is convective difference. But in local change, you focus on only one student. So what are the marks of the student in mid-semester? What are the marks of the student in final semester? And how the performance of the student is changing? That will become the local change. So you focus on one point, and at the point, how the property value is changing with the time, that will become the local change. ठीक है? तो इस तरह से ये Eulerian approach बनती है. अच्छा. Now, before digging into the questions of this, I would like to add one point in Eulerian approach. So, you can make a note of that. You can make a note of that and write it down. Okay? So how will I introduce the note? Actually, what I want to say, the rate of change of property with time. The rate of change of property with time, that is given as u del p by del x, u del p by del x plus v del p by del y plus w del p by del z plus del p by del time. Something like this I am going to write down. Okay, and don't worry, I will show you an example of this. बिल्कुल टेंशन नहीं लेने का, अभी ये एग्जाम्पल बताते हैं, इसका एग्जाम्पल बताते हैं, ठीक है. सो लेट अस से फॉर एग्जाम्पल, टू अंडरस्टैंड दिस, लेट मी टेक द प्रॉपर्टी. कौन सा प्रॉपर्टी ले? से फॉर एग्जाम्पल, let us take x component of velocity as the property. Which component of velocity we will take? X component of velocity as the property. So in Eulerian approach, this is how you write down any property. Property as a function of position and time. So what is the meaning of this? The meaning is, at what is the value of velocity component? What is the value of velocity component at point x comma y comma z when the time value is t? ठीक है? What is the value of velocity component at point x comma y comma z when the time is t? So how does it look physically? It looks physically like this. So I can observe that 7-8 people are there. तो बेटा आप लोग अगर डाउट पूछोगे, चीजें बताओगे, तो मुझे तभी पता लगेगा कि whether these sessions are beneficial for you or not, है ना? तो all those people who are watching the video, again I am telling, a 150-day course of GATE is going on this platform, YT platform, YouTube platform. So the subjects are running alternate day basis. So those people who do not have resources and they want to prepare for GATE, IAS, DRDO, ISRO exam, so they can use these lectures. But it would be good if you watch the lectures from beginning. This is the 6th lecture of fluid mechanics. Matlab we have not gone too far into fluid mechanics, not gone too deep into fluid mechanics. We have only discussed the prerequisites, and now for some days we will discuss Eulerian Lagrangian approach. तो बीच-बीच में बताते रहना कि कहाँ दिक्कत चल रहा है. तो velocity at x, y, z when the time is t. So velocity at the point x, y, z, velocity at the point x, y, z inlet of the turbine when the time is t, when the time is 3 p.m. What is the value of velocity in the afternoon at the inlet of the turbine? This is the function written. ठीक है. Now even though this function is written for a point, but a point will not move, है ना? So what is this? This is the velocity of particle at the point. This is the velocity of particle at the point. Now obviously when the particle will move ahead, its velocity might change also, है ना? So what you will do? You will write down acceleration of the particle. What you will write down? Acceleration of the particle. And what is the definition of acceleration? So definition of acceleration is the x component of acceleration is equal to du by dt. है ना? So for a particle, the acceleration will be the rate of change of its velocity. But in Eulerian approach, the velocity is a function of position and time. है ना? बहुत ध्यान से सुनना है मैंने क्या किया है. बहुत ही ध्यान से सुनना है मैंने क्या किया है. ये थोड़ा सा confusing हो सकता है. So what I said, velocity is defined for a point. But point cannot move. So actually it is the velocity of particle at the point. And for a particle, the rate of change of velocity is acceleration. So this is the acceleration of particle at the point. ठीक है? This is the acceleration of particle at the point. एक बार देख लो, अभी भी देख लो, अगर कोई दिक्कत लगे तो 1 मिनट लेके देख लो, कोई दिक्कत लगे तो. ठीक है? Now I hope you remember that if z is a function of 2 variables. I hope you remember this because some partial calculus is involved over here. If z is a function of x and y, then the derivative of z will be written as the derivative of z, partial derivative of z with respect to x into dx plus partial derivative of z with respect to y into dy. I hope you remember this. And when we say partial derivative means during this derivative, we will treat y as a constant. Del z by del x. This means all the remaining variables will be treated as constant. Similarly, del z by del y, all the remaining variables. What are the remaining variables? X is the remaining variable. So x will be treated as constant. I think एक example भी लिख ही लेते हैं इसका, है ना? एक example भी लिख ही लेते हैं. So let me take some space over here. यहाँ पे space बनाता हूँ, मेरा वीडियो हटाता हूँ. Note this down in rough only. So say for example, z is equal to maybe x square y plus x. Let us say like this. Okay? Z is equal to x square y plus x. So when I write down del z by del x, what will be the answer? What is del z by del x? What is del z by del x? Who would like to tell what is del z by del x? भैया 7 लोग वीडियो देख रहे हैं. So जो लोग भी वीडियो देख रहे हैं, please do let me know. Obviously one of you is me only. I am also watching the video side by side. तो एक जना तो मैं खुद ही हूं, बट बाकी लोग भी कमेंट करके बताएं. What will be del z by del x? Sir, when we are doing del z by del x, y will be treated as a constant. So sir, y will become a constant. Sir, if y is a constant, what is the derivative of x square? It will be 2x. So 2xy. And what is the derivative of x? 1. So this is del z by del x. Similarly, if I find out del z by del y, sir, x will be treated as constant. So x square is a constant. So what is the derivative of y? 1. So this will become x square, which is a constant, and derivative of y is 1 plus derivative of constant. So derivative of constant is 0. So del z by del y will be x square. So if someone asks us, what is the total derivative dz? What is the total derivative dz? So you will say del z by del x, that is 2xy plus 1 into dx plus del z by del y, that is x square into dy. So this is the total derivative dz. ये आपका total derivative dz आएगा. Clear है? I hope this is clear. If anyone has a doubt, please do let me know. Vishnu, Aisha, beta, if any one of you is there, please do let me know. Clear or not? Clear or not? Clear or not? Now check, guys. In our case, u is a function of 4 variables. And we are taking the derivative of u with respect to time. है ना? We are taking the derivative of u with respect to time. Let me do one thing. Let me write it on the other slide. So what I have? I have the x component of acceleration is equal to du by dt. X component of acceleration is equal to du by dt, where u is a function of 4 variables. So what will happen? This will become del u by del x into dx by dt, del u by del x into dx by dt, plus del u by del y into dy by dt, plus del u by del z into dz by dt, plus del u by del time into d time by dt, del u by del time into d time by dt. ठीक है ना? ठीक है? So what is this? This is the x component of acceleration at point x comma y comma z when the time is t. Or you can also say this is the x component of acceleration for the particle which is crossing xyz when the time is t. ठीक है ना? ऐसा दोनों स्टेटमेंट यूज कर सकते हैं. क्या कह सकते हैं? ax is the acceleration. So acceleration component, obviously the acceleration component, ax is the acceleration component at xyz, at point xyz when time is t. Or It is the acceleration of the particle crossing xyz at time t. Acceleration of particle which is crossing xyz at time t. Crossing xyz at time t. Which is crossing xyz at time t. xyz at time t. ठीक है, तो आप ये दोनों डेफिनेशन लिख लीजिए. आई नो थोड़ा सा ट्रिकी है, but this is why I am doing Eulerian and Lagrangian approach before any other chapter. This is why I am doing this topic before any other chapter, so that when we go to the actual fluid kinematics and dynamics, you will have time to revise this topic, and therefore you can become master of this topic till that time. ठीक है ना, आपको अच्छा खासा टाइम मिल जाएगा. इन बिटवीन आई विल गिव यू क्वेश्चंस ऑफ दीज. आप वो क्वेश्चन प्रैक्टिस करेंगे तो आपको ये चीजें अच्छे से समझ आएंगी. नाउ गाइस चेक. सो एक्सेलरेशन एट अ पॉइंट व्हेन टाइम इज t, और एक्सेलरेशन ऑफ द पार्टिकल क्रॉसिंग द सेम पॉइंट एट द सेम टाइम. ठीक है. Now even though we are defining this for a point, but this is for a particle. So for a particle, what is dx by dt? So dx by dt, the rate of change of position, है ना? So this is the rate of change of x coordinate. This will be the rate of change of y coordinate, rate of change of z coordinate. So that becomes x component of velocity, y component of velocity, and z component of velocity. So what will happen? You can write ax is equal to, which is du by dt. Ax is equal to du by dt. You can write it as u del u by del x plus v del u by del y plus w del u by del z plus del u by del time. You can write like this. ठीक है ना? So this is what happens in the last. ये आपके पास last expression आया है. वेरी गुड आदर्श, बहुत बढ़िया बेटा. आदर्श पता है क्या है बेटा, देख, अगर एग्जाम पॉइंट ऑफ व्यू से कंप्लीट करना है तो एक तो डीएस कुमार खरीद लो, क्योंकि उसका ऑनलाइन वर्जन आसानी से मिलता नहीं है. डीएस कुमार ले लो, और साथ में सोम साहब की किताब का वर्जन डाउनलोड कर लो. 2 किताबें रखोगे तो वो भी सफिशिएंट है. मगर मैं ऑलरेडी इन सेशंस में क्वेश्चन देता ही हूं, है ना? तो अब पहले तो क्वेश्चन, अब मतलब अब क्वेश्चन बढ़ते जाते हैं मेरे केस में भी डेली. तो मैं भी क्वेश्चन देता ही हूँ जो ऑलरेडी डीएस कुमार से है, सोम साहब की किताब से है, सेंजल से है, मनसुन यंग से है ना, कितने सारे सोर्सेज से हैं. अभी कल की क्लास में मैंने गेट एक्सी के भी क्वेश्चन दिए थे होमवर्क करने के लिए. तो आप यहाँ वाले भी क्वेश्चंस कंप्लीट कर लोगे तो आपकी प्रिपरेशन कंप्लीट रहेगी. इस बार गेट में जितने भी क्वेश्चंस आए थे एक्सेप्ट फॉर वन क्वेश्चन ऑफ हीट ट्रांसफर, दे वर आइदर फ्रॉम रेगुलर क्लासेस और फ्रॉम यूट्यूब क्लासेस. जो मैंने रेगुलर क्लास किया है या यूट्यूब क्लास किया है, सारा क्वेश्चन उधर से ही आया था. इनफैक्ट गेट के क्वेश्चन जो हैं हमारे क्वेश्चन के पार्ट थे. अगर हमारे क्वेश्चन में 3 पार्ट है तो गेट का क्वेश्चन जो है उस क्वेश्चन का 1 पार्ट था. तो अगर आप ये क्वेश्चंस कंप्लीट करोगे, मैं आपको गारंटी देता हूं आपको कहीं और जाने की जरूरत नहीं है बेटा. सारी चीजें कवर हो जाती हैं क्लासेस में और यूट्यूब सेशन में, प्रैक्टिस सेशन में. ठीक है. ओके, सो what we have done, we have written acceleration at a point. And what is acceleration? Acceleration is the rate of change of velocity. So rate of change of velocity at the point, or rate of change of particle at the rate of change of velocity for particle at the point. ठीक है. Rate of change of velocity at the point, इसका मतलब क्या है? What is the meaning of this? The rate of change of velocity for particle at the point. ठीक है. So like you have written ax, similarly you can find out ay also. So what will be ay? Ay will become dv by dt. But just like ax, what will happen? It will be u del v by del x plus v del v by del y plus w del v by del z plus del V by del time. Del V by del time. This is how you will write AY. Del V by del time. And remembering this is very easy. How? When you are writing AX, AX is what? AX is the time rate of velocity. AX is the time derivative of U. So what you do? You write all the partial derivatives of U. All the partial derivatives of U and multiply the first three partial derivatives with the corresponding velocity components. ठीक है? कैसे? कैसे? Say for example, I want to write down AZ. I want to write down AZ. So how will I write down AZ? AZ I will write it as dw by dt, right? Now w is a function of x, y, z and time. So I will write all partial derivatives of w. So del w by del x, del w by del x, del w by del y, del w by del z and del w by del time. ठीक है? Now what you do, the first three derivatives which are respect to position coordinates, which are with respect to space coordinates. Now first three derivatives you multiply by corresponding velocity components. So this is a derivative with respect to x, है ना? So you multiply by x component of velocity. Derivative with respect to y. So multiply by y component of velocity and similarly multiply by z component of velocity and then add all the terms. So these are your respective acceleration terms. These are your respective acceleration terms. So this is how we are going to write acceleration in Eulerian approach. This is how you are going to write acceleration in Eulerian approach. Acceleration in Eulerian approach. And I think it would be good. It would be good if we solve a question on this. तो चलो फिर क्वेश्चन करके देखते हैं, ठीक है ना? So क्वेश्चन करते हैं, क्वेश्चन से बेटर होगा काम. So firstly, I am not taking a gate question. I am taking a practice question. I am taking a practice question. So this particular question is from DS Kumar. This particular question is from DS Kumar. Okay. So guys, go through the question once and just give me a moment. I'll get some water for me. एक बार क्वेश्चन को go through करो और मैं थोड़ा सा पानी लेके आता हूं अपने लिए. Okay, so guys, I hope you have gone through the question. I hope question को read किया. Now check. So हर को अभी time है. We are in May. So June, July, August, September, October, November, December, है ना? So you have some time that while doing the questions in the class, you try to understand each and every aspect of the question. Please don't be in a hurry to solve the question. Understand the question. Spend some time on understanding the question, finding out the peculiarities of the question. Okay? So, say for example, but this is a very simple question only. There is not much to talk about this in the question, but I am saying in general. Okay? So it says the velocity components expressed in meter per second in a fluid flow. So velocity component means UVW are known to be U is equal to 6xy square plus t, V is equal to 3yz plus t square plus 5, and W is equal to 2 plus 3ty, where x, y, z are given in meters and time t is in seconds. Determine the magnitude of velocity and acceleration at a point when the time is 3 seconds. Okay, this is the question written. So read it again. The velocity components are expressed like this. Now I hope you can observe velocity components are expressed as functions of space coordinates. How the velocity components are expressed? Functions of x, y, z. In Lagrangian approach, when you describe a flow, in a Lagrangian approach, you talk about particles. So what you say? You say position of particle A is a function of time. And obviously this will be a pure function of time. So you will say x coordinate of particle A, which will be a function of time, y coordinate of particle A, which will be a function of time, and z coordinate of particle A, which will be a function of time. And when you differentiate it, you get the velocity. So what you will get? You will get u, v and w. But these u, v and w, they will be pure functions of time. है ना? Lagrangian approach में कैसे लिखते हो? Velocity of particle as a function of time. मगर यहां पे क्या लिखा हुआ है? Velocity as a function of x, y, z and time. So this is not Lagrangian approach. This is Eulerian approach. है ना? Because velocity is expressed as function of position coordinates. So this will only mean what they are trying to say. They are simply trying to say that this is the coordinate system. This is the coordinate system. In the coordinate system, we have a point x, y, z. So when the time is t, the velocity at point x, y, z is this. The velocity at point x, y, z is this. So they are talking in Eulerian approach. Now these are the velocity components for a general point x, y, z and for a general time. But they are asking you the velocity for a particular point 4, 1, 2 and that too for a particular time. So what will happen? In your expression, x will become 4, y will become 1 and z will become 2 and the time value will become 3 seconds. So to find the velocity, we have to do only one thing. We have to replace x with 4, y with 1, z with 2 and time with 3. So you will get your answer. है ना? So let me solve it. So what we know, velocity u at x, y, z, velocity u at x, y, z when the time is t. How much is this one? मैं same question को दूसरी slide पे देख लेता हूँ ताकि मुझे access करना आसान हो. So velocity at x, y, z when the time is t, this is equal to 6xy square plus t. But they are talking of velocity component at 4, 1, 2 when the time is 3 seconds. है ना? So what will happen? This will become 6 into 4 into 1 का square plus time which is 3. So I think this will become 27 units, 27 meter per second. Okay? So for our concerned point and concerned time instant, this is the x component of velocity. Similarly, you will say y component of velocity at x, y, z when the time is t. So how much is this equal to? This is equal to 3yz plus t square plus 5, right? But we are concerned with 4, 1, 2, 3. So what will happen? This will become 3 into 1 into 2 plus t square, that is 3 ka square plus 5. So I think this will become 6 plus 9. So 6 plus 9 is 15. 15 plus 5 is 20. So 20 units. And unit is given as meter per second. X is in meters, time is in seconds. Now similarly you will find out W. So W will be W as a function of x, y, z and time. So W at x, y, z when time is t. So this is given as 2 plus 3ty. But we are concerned with point 4, 1, 2 when time is 3 seconds. So this will become 2 plus 3 into 3 into 1. So 3 into 3 is 9. 9 plus 2 is 11. So this will become 11 units. Correct? Correct? So what you will say? You will say at the point 4, 1, 2. At the point 4, 1, 2 when the time is t. When the time is 3 seconds. When the time is 3 seconds. The x component of velocity at the point 27 units. Y component of velocity at the point 20 units. Z component of velocity 11 units. So if you want to write in vector form, velocity vector at 4, 1, 2 when the time is 3 seconds. This is equal to 27 I cap plus 20 j cap plus 11 k cap. And obviously you can find out the magnitude also. आप लोग magnitude भी find out कर सकते हैं. तो magnitude कैसे आएगा? Magnitude आएगा 27 का square plus 20 का square plus 11 का square under root. This will be the magnitude, right? So check the magnitude please. Check the magnitude. मेरे को भी calculate करना पड़ेगा. Calculate कर लेते हैं. So 27 square plus 20 square plus 11 square. So if you take under root, this is 35.355 meter per second. 35.355 meter per second. Kindly check if this is clear or not. Please check if this is clear or not. जल्दी से check करेंगे. जल्दी से check करेंगे if this is clear or not. Others and anyone else who is watching the video, please do let me know if this is clear or not. Please do let me know if this is clear or not. I hope this is clear. I hope this is clear. Huh? Now we have to find out the acceleration also. Acceleration at the same point 4, 1, 2 when the time is t. So they are asking you acceleration at a point. They are asking you Eulerian approach. What are they asking? Eulerian approach. Now in Eulerian approach, how we write the acceleration components? Hi Keshav, how are you? ठीक है, very good आदर्श, बेटा बहुत बढ़िया. थोड़ा सा ध्यान रखना क्योंकि आगे आने वाला क्वेश्चन थोड़ा डिफरेंट है. ठीक है, अभी हम टेम्परेचर फील्ड और प्रेशर फील्ड का भी चेंज देखेंगे तो वो थोड़ा सा डिफरेंट है. So when you will find out acceleration, so how do you write acceleration in Eulerian approach? So in Eulerian approach, acceleration is written as u del u by del x plus v del u by del y plus w del u by del z plus del u by del time. Del u by del time. Actually, this particular question will look a little lengthy. ये पर्टिकुलर क्वेश्चन जो है ना थोड़ा लेंथी लगेगा, बट द पॉइंट इज इट विल गिव यू अ प्रैक्टिस एंड आई विल शो यू हाउ क्वेश्चन कम्स इन गेट एग्जाम ऑल्सो. ठीक है, एक बार ये क्वेश्चन कंप्लीट कर लेते हैं. ये थोड़ा सा लेंथी जरूर है मगर इससे पार्शियल डेरिवेटिव्स लिखने की प्रैक्टिस हो जाएगी और फिर मैं आपको दिखाता हूं कि गेट एग्जाम में क्या क्या क्वेश्चन आए हैं. ठीक है, तो ये देखो. नाउ व्हाट विल दिस गिव यू? This will give you acceleration at a point x, y, z when the time is t. This will give you acceleration at a general point for general time. ठीक है? So first of all, let us find out this general expression. पहले ये general expression find out करते हैं क्योंकि एक बार general expression आ गया तो उसमें x की जगह 4, y की जगह 1, z की जगह 2 और time की जगह 3 रख देंगे तो हमारा आंसर आ जाएगा, है ना? But first of all, we have to find out the general expression. Now for general expression, I will need u. So how much is u? U is equal to 6xy square plus t. So Adarsh, Keshav, beta, what will be del u by del x? What is going to be del u by del x? What will be del u by del x? I think for del u by del x, so remaining variables will be constant. Y will be constant, time will be constant, Z will be constant, right? Y, Z and time will be constant, है ना? So y square will be constant, time will be constant. So what is the derivative of x? the derivative of x is 1. So this will become 6y square plus time. Time is a constant. What is the derivative of constant? 0. So del u by del x will be 6y square. हाँ यस सिमिलर क्वेश्चन ही आते हैं. मैंने पहले ही बोला ना, आप क्लास में जितने भी क्वेश्चन करेंगे वही क्वेश्चन आपके एग्जाम में आएंगे. ये मैं आपको 100% गारंटी देता हूं. इस साल गेट में जितने भी क्वेश्चन आए थे वो रेगुलर क्लास या यूट्यूब सेशन से आए थे, और ऐसा बाकी एग्जाम्स में भी होगा. मैं आपको 100% गारंटी देता हूं. बस आप ये सारे क्वेश्चन जो है ना समझ के करने हैं. Now similarly, yes, very good. We would need del u by del y also, very good. But when we do del u by del y, x, z and time will be constant. So for del u by del y, x will be constant, time will be constant. Now what is the derivative of y square? It is 2y. So that will become 12xy. And plus time is a constant. So derivative of constant will be 0. I will also need del u by del z. I will also need del u by del z. So when you say del u by del z, when I am saying del u by del z, so x, y and time will be constant. So this entire is a constant. So what is the derivative of constant? It is 0 only. So you can say like this also. U is not a function of z. So del u by del z will be 0. U is not a function of z, so del u by del z will be 0. And then in the last we need del u by del time. We also need del u by del time. Now del u by del time, x, y, z will be constant. So x, y, z will be constant. So what is the derivative of t? Derivative of t is 1. So del u by del t will be 1. Okay, na? So you guys are totally correct. You guys are totally correct. Now let us find out the expression of ax. So ax is equal to u del u by del x. Therefore 6xy square u del u by del x. Therefore 6xy square plus t, that is u, into del u by del x, that is 6y square, plus v del u by del y. I think I should remove my video. V del u by del y. So how much is v? Expression of v was given to you, है ना? So expression of v was 3yz plus t plus 5 into del u by del y. V del u by del y. And how much is del u by del y? 12xy. Plus w del u by del z. Now this we don't need to worry because del u by del z is 0. So this will become 0 only. Plus del u by del time, which is 1. I think this is what we are getting for ax. Obviously, very lengthy expression. So this is the general expression of ax. And you can simplify it by opening the terms. If you want, you can simplify it by opening the terms. So what will happen? This will become, if you want, you can open the terms, but I am leaving like this only. Now they want the value of acceleration at 4, 1, 2 when the time is 3 seconds. है ना? So what will happen? Against x you will put 1, 4. Against y you will put 1. Against time you will put 3. And against z you will put 2. So you will get your answer. So this will become 6 into 4 into 1 ka square plus t, that is 3, into 6y square. So 6 into 1 ka square. Plus 3yz, so 3 into 1 into 2, plus t, that is 3, plus 5, plus 12 into 4 into 1, that is, not plus, multiply, 12xy. So 12 into 4 into 1, okay? And then there is a plus 1 in the last. There is a plus 1 in the last. तो check करो क्या final answer आया. थोड़ा lengthy आ रहा है, कोई बात नहीं. बट अभी हम गेट और आईएएस जैसा क्वेश्चन देखते हैं कि उनमें कैसा क्वेश्चन आ जाता है, तो अपने आप आपको पता लग जाएगा कि सिंपल आएगा वहां क्वेश्चन. सो गाइस check how much you are getting. So 6 into 4 is 24, 24 plus 3 is 27, 27 into 6, 27 into 6, that I am getting as 162, plus 3 into 2 is 6, 6 plus 3 9, 9 plus 5 14 and 14 into 12 into 4. काफी बड़ा आ रहा है ना यार ये वैल्यू, काफी बड़ी आ रही है वैल्यू। चेक करो गाइस कितना वैल्यू आ रहा है। सो प्लस 672 प्लस 1, सो ये आ रहा है 162 प्लस 672 प्लस 1। अरे बाप रे 835 यूनिट्स आ रहा है, 835 यूनिट्स आ रहा है मीटर पर सेकेंड स्क्वायर। केशव बेटा 1408, अरे 1408 तो एक मूवी का नाम है, यू नो 1408 इज अ मूवी, सो इट्स अ हॉरर मूवी वेयर देयर इज अ रूम नंबर कॉल्ड एज 1408। हाँ मतलब देखा जाए सो यस दिस इज अ हॉरर मूवी ओनली, हॉरर मूवी जैसा ही लग रहा है। ओके सो दिस is the value of x component of acceleration. So like this you will find out one component of acceleration. ऐसे आपके पास एक component आएगा acceleration का। Now in a similar manner you will find out, तो काफी lengthy है, so I am not doing it and I am leaving this up to you। काफी lengthy है, so I am not doing it, I am leaving this up to you। So ay is equal to u del v. Now please remember for ay you will take u del v by del x plus v del v by del y plus w del v by del z and del v by del time. But please remember this will be a general expression. In the general expression you have to put the concerned point and the corresponding time also. तो इससे आपको general expression मिलेगा। और फिर अगर हम az मिलेंगे, az लिखेंगे तो az में क्या आएगा u del w by del x प्लस v del w by del y प्लस w del w by del z प्लस del w by del time, है ना। तो ये आप करके देखना। अब आप बोलोगे साले ने कल्टी खा लिया, इसको पता लग गया कैलकुलेशन बहुत लंबी है तो कर नहीं रहा है ना। क्या करूं यार, इतनी लंबी कैलकुलेशन करके टाइम वेस्ट हो जाएगा, कोई फायदा नहीं है मेरे को, है ना। एक्चुअली मैं कुछ और भी कराना चाहता हूं इसलिए। तो यू कैन सॉल्व दिस। नाउ वंस यू गेट ay, once you get az, what will be the resultant acceleration vector? The resultant acceleration vector will be ax I cap plus ay j cap plus az k cap. And if you want to write down the magnitude will be under root of ax square plus ay square plus az square. Magnitude will be this. Magnitude is going to be this. ठीक है, करेंगे इसको कंप्लीट। देन आई विल शो यू द गेट पैटर्न ऑफ क्वेश्चंस। फिर मैं गेट पैटर्न ऑफ क्वेश्चन दिखाता हूं। आदर्श हंस रहा है, मजाक उड़ा रहे, क्या करूं यार इतना लंबा, अब देखो इतना लंबा कैलकुलेशन है क्या है ना, तो लंबा था, लेंथी कैलकुलेशन था। ठीक है, नाउ चेक gate pattern. So this question has come actually in both the branches, civil also, mechanical also. So this question was, a flow field is given by a flow field. What? A flow field. So what do you mean by field? What do you mean by field? Actually, whenever you describe something as a function of position and time, that is called as field. यानी कि ये जो प्रॉपर्टी का डिस्क्रिप्शन है ना, प्रॉपर्टी एज अ फंक्शन ऑफ पोजीशन एंड टाइम which we do in Eulerian approach, that is called as field. So whenever the field word is written, that is Eulerian approach only. ठीक है, a flow field is described by, so velocity vector 4x I cap minus 4y j cap. I hope you have seen this question, है ना। माइनस 4y j कैप। आई होप, मेरे को लगता है ये आपने क्वेश्चन देखा होगा जरूर कहीं ना कहीं, कॉमन क्वेश्चन है ये, बहुत एग्जाम्स में आता है सेम वैल्यूज के साथ। सो दे आर सेइंग द वेलोसिटी फील्ड, द फ्लो फील्ड इज डिस्क्राइब्ड बाय वेलोसिटी वेक्टर दिस। Flow field. Field means, flow means there is a space, fluid is moving, and field means we are describing the space by Eulerian approach. So for the flow, velocity vector is given like this. Now they are asking, find out the acceleration vector. Find out the acceleration vector at the point 2, 2. Actually, when it came in mechanical, the options were in vector form. And when it came in civil, the option was in numerical form, single numerical value. So in mechanical question, you had to find out the vector, and in civil question, you had to find out the magnitude of the vector. ऐसा समझ रहे हैं आप? So what they are asking? They are asking acceleration vector at 2, 2. So first of all, what you will say? You will say velocity vector equal to 4x I cap minus 4y j cap. So when we say I cap, the term with I cap, that is nothing but the x component of velocity. So obviously this is u. The term with y cap, j cap, this is the y component of velocity. So obviously this is v. So when I am writing the x component of velocity for the flow, it is 4x. And when I am writing the y component of velocity, it is minus 4y. So physical meaning क्या बनेगा? Physical meaning याद करते हुए चलो, हमेशा बार बार, चाहे बार बार हो रहा है मगर फिर भी करो, तभी तो प्रैक्टिस बनेगा ना, तभी तो स्ट्रांग होंगे। सो व्हाट इज द फिजिकल मीनिंग? फिजिकल मीनिंग इज इफ आई टेक x, y, z as a general point, if I take x, y, z a general point, then when the time is t, the x component of velocity at the point is 4 times the x coordinate of the point. Y component of velocity at the point is negative of 4 times the y coordinate of the point, and in the velocity vector there is no k cap. This means it is 0 k cap, so w is going to be 0. So there is no velocity along z direction. ठीक है ना? तो at point x, y, z, when the time is t, these are the velocity components. Now at the same point there will be acceleration components. So how do you write acceleration components? You write acceleration components as u del u by del x, u del u by del x plus v del u by del y plus w del u by del z plus del u by del time. है ना? This is how you write acceleration components. So this is your first acceleration component. Now please check how much is u equal to 4x. So what will be del u by del x? Obviously del u by del x will be 4. What will be del u by del y? Sarji, when we are differentiating with respect to y, x and z and time will be constant. So x, z and time will be constant. So x is a constant. This is a constant. So when we take a derivative of constant is 0. Or you can say in the other manner, u is not a function of y, so derivative will be 0. Similarly, u is not a function of z, so derivatives will be 0. And similarly, u is not a function of time, so again the derivative will be 0. तो ये छोटा simple idea बन गया है ना? Correct or not? Correct or not? So these remaining derivatives are 0. Now our expression is very easy because del u by del y is 0, del u by del z is 0, del u by del time is 0. So in this particular question, your ax is only equal to u del u by del x. But how much is u equal to? It is 4x. How much is del u by del x equal to? 4. So this will become 16x. So this is the general expression of ax. So acceleration at x, y, z when time is t. Acceleration at x, y, z when time is t. बहुत सिंपल है ना ये तो? गेट क्वेश्चन तो बहुत सिंपल है. तो क्या हो गया? अब ये तो ax आ गया. Similarly, you have to find ay also. I'm going to the next slide. Quickly note down. By the way, these are simple questions. These are टॉफी खाने वाले क्वेश्चन है. ये बहुत सिंपल क्वेश्चन है. अभी हम क्या करेंगे? In the next class, we will elaborate this. What is the meaning of the first 3 terms? What is the meaning of the 4th term? So first three terms, they are called as local acceleration. The fourth convective acceleration. The fourth term there, this is called as local acceleration. So this is maths. This is mathematical definition of convective acceleration. What is the physical meaning? तो ये सब चीज हम देखेंगे, ठीक है? ये हम नेक्स्ट टाइम देखेंगे, कंटिन्यू करेंगे जब आगे. आज अभी हम क्वेश्चन करेंगे 2-3 और. Now AY also. So when you will say AY, that will become U del V. Please note AY. So when I have AY, how will I write? AY means the derivative of Y component. So rate of change of Y component of velocity. So del V by del X, del V by del Y, del V by del Z, and del V by del time. Del V by del time, है ना? And what we will do? First three terms we will multiply by corresponding velocity components X, Y, and Z. So X component of velocity is U, Y component of velocity is V, and Z component is W. And then you will add all the terms, है ना? This is how it will happen. Now how much is V equal to? V is equal to minus 4Y. So minus means negative direction, opposite direction, है ना? So what will be del V by del X? Sir ji, V is not a function of X. 0. What will be del V by del Y? So derivative of Y is 1. So this will be minus 4. What will be del V by del Z? Sir ji, V is not a function of Z. So this will be 0. And V is not a function of time. So this will also be 0. So these terms are 0. So bhaiya, this term is 0. Del V by del X, del V by del Z, del V by del time. I think very easy. Now how much will be the AY value? So AY value is equal to V del V by del Y in this case, V del V by del Y in this case. So AY is equal to minus 4Y into minus 4. That is 16Y. है ना? 16Y. And what about AZ? AZ भी तो निकालोगे? AZ भी तो निकालोगे? What about AZ? What will you say about AZ? What will you say about AZ? Anyone? What will be the answer for AZ? I can see there are 9 people watching. बाकी लोग भी बता दो. बताऊं क्या है? देखो क्या होता है, अगर मुझे क्लास में पता नहीं लगेगा ना कि किसको समझ आ रहा है, किसको समझ नहीं आ रहा है, तो मैं अपनी कहानी चलता जाऊंगा. मैं भी बीच में 5 मिनट बाद बोर हो जाऊंगा. मुझे भी लगेगा कि क्या मैं अपने आप को ही पढ़ा रहा हूं. मेरा गेट एग्जाम तो 10 साल पहले ही हो गया था. समझ लो? तो इसलिए पूछता हूँ बीच बीच में कि बता दिया करो. वेरी गुड. सो आदर्श एंड केशव आर गिविंग आंसर. अदर्स ऑल्सो शुड रिप्लाई. सो वेरी गुड आदर्श, वेरी गुड केशव. थोड़ा सा गड़बड़ आ रहा है यार. एक जना अच्छा 32 कह रहा है, एक जना 45.25 कह रहा है. सो गाइस देखो, so in our velocity field, so they were saying the velocity field of the flow is this. Velocity field of the flow is this. Means they were telling you the information of entire velocity vector, है ना? Entire velocity field. Now in the entire velocity field, so I said if this is the entire velocity field and k term is not there, so obviously W is 0, है ना? So in the entire velocity field, if the k term is not there, so obviously W is 0. This means whatever the point is, x, y, z. So general point, at general point W is 0. General means any point. So at every point W is 0. So there is no motion along Z direction. There is no motion along Z direction. If there is no motion along Z direction, there is no acceleration along Z direction. है ना? यही बनेगा बात, यही बनेगा. So W is a 0. Whatever is the point. So del W by del X 0, del W by del Y 0, del W by del Z, del W by del time. So AZ is 0. तो क्या बन गया? क्या बन गया? What will be the acceleration vector? क्या केशव, क्या चीज? ऐसा थोड़ी होता है सर, मैं समझा नहीं बेटा. What will be the acceleration vector? That will be AX I cap plus AY J cap plus AZ K cap, है ना? So this will be 16x I cap plus 16y J cap plus 0 K cap. Now you will ask me, this was the general expression, but they are asking you the acceleration at 2, 2. So this will obviously become 32 I cap plus 32 J cap, and obviously you can find it out कि under root of 32 का square plus 32 का square. So if you find out the magnitude will be 32√2. The magnitude will be 32√2. ठीक है, ये आपका एक्सेलरेशन का मैग्नीट्यूड आ गया, तो ध्यान रखो। हाँ केशव बेटा, कंसेप्ट से रिलेटेड कह रहे थे या कुछ और कह रहे थे? कंटेंट से रिलेटेड तो नहीं कह रहे थे, क्योंकि मैं समझा नहीं बेटा, मैंने मिस आउट कर दिया। पॉइंट से रिलेटेड तो नहीं कुछ कह रहे थे? ओके, नाउ हैव अ लुक एट नेक्स्ट क्वेश्चन. Such questions you might not observe in civil or mechanical paper, the next question which I am giving, but you might get such question in XC paper. XC paper में आपको ऐसा क्वेश्चन जो है मिल सकता है, सो चेक करो. अच्छा जोक था, ठीक है, हंसी मजाक जितना मर्जी करो, मेरा भी जितना मर्जी मजाक उड़ाओ, मत बस गाली वाली मत देना. ठीक है, बस ये पढ़ाई भंग नहीं होना चाहिए बिल्कुल भी. चलो रीड द क्वेश्चन प्लीज, रीड द क्वेश्चन प्लीज. सो कहता है गिवन एन, सो दिस इज अ क्वेश्चन फ्रॉम सोम साहब की किताब. गिवन एन अनस्टेडी टेम्परेचर फील्ड. Till now I have not discussed what is the meaning of unsteady. So unsteady means that a property is a function of time. What is unsteady? So मतलब अगर grammar, अगर dictionary देखें, so in dictionary unsteady means something which changes with the time. Something which changes with the time. ठीक है? So have a look at the previous example. What was the previous example? The previous example which we discussed last time and we revised today also. The previous example said कि if this is a fan, ठीक है, and let us take a point over here, A point. So at 9 a.m. only the fan is running. So velocity at the point is in this direction. But at 2 p.m. the AC is also running. So velocity at the same point is in this direction. So velocity at the point 9 a.m. Velocity at the point 2 a.m. 2 p.m. So velocity at a point is changing with the time. So velocity is a function of time. This means velocity is an unsteady parameter. Velocity कैसा parameter है? Unsteady parameter है. But please remember, when you are checking the steadiness of a system, you focus on one point like this and you check how the property value at the point is changing with time. ठीक है? When you check steadiness, you do not compare two points. You do not compare inlet and outlet of the pump, inlet and outlet of the turbine. आप दो पॉइंट्स को कंपेयर नहीं करते. यू फोकस ऑन ओनली वन पॉइंट. सो आई विल फोकस ओनली ऑन द इनलेट ऑफ द टर्बाइन एंड आई विल सी हाउ द प्रेशर और वेलोसिटी एट इनलेट ऑफ टर्बाइन इज चेंजिंग विद टाइम. So if it is changing with time, then it will be unsteady, and if it is not changing with the time, then it will be steady. If it is not changing with the time, then it will be steady. ठीक है? So say for example, एक एग्जाम्पल देख लेते हैं, छोटा सा एक एग्जाम्पल देख लेते हैं. ठीक है? So say for example, this is a pipe in our bathroom. So and there is a tap. We also know tap has a valve which helps to control the flow rate. So when the valve is closed, there is no flow. When the valve is half open, there will be a flow of 0.5 liter per second. And when the valve is fully open, there will be a flow of 1 liter per second. है ना? सही है ना? Now guys check. Let me say from time t. Okay. So from time t equal to 0 to t equal to 10 seconds. Okay. From time t equal to 0 to t equal to 10 seconds. The valve is half open. Valve is what? Half open. Valve is half open. Okay. And when you will focus on the outlet of the tap, आप कहां पे फोकस कर रहे हैं? टैप के आउटलेट पे फोकस कर रहे हैं. I said ना, for steadiness we do not compare two points. we focus on one point. So let us say, for example, we are focusing on outlet of the tap. So initially the tap is half open. So the discharge which you are getting from the outlet is 0.5 liter per second. Later on also the tap is half open. So discharge you are getting from the tap is 0.5 liter per second. So with the time, what is happening to the discharge value from outlet? With the time, what is happening to discharge value from outlet? Bolo? 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 Initially also the valve was half open, so we are getting a flow rate of 0.5 liter per second. Later on also the valve is half open, so we are getting a flow rate of 0.5 liter per second. So at the outlet of the tap, the discharge is constant. It is not changing with the time. So discharge is constant. So this is a steady state flow condition. कैसा condition है ये? Steady state flow condition है. Discharge is not changing with time. Now what you will do, you will start opening the valve slowly, and it will take a total of 10 seconds to open the valve completely. So from at t equal to 10 seconds, the valve was half open. At t equal to 20 seconds, the valve is fully open. So what will happen? The discharge will increase. So flow rate will increase from 0.5 to 1 liter per second. So if I consider t equal to 10 seconds, what is the initial discharge from outlet? 0.5. T equal to 20 seconds, what is the discharge from outlet? 1. So discharge is changing with the time. So discharge is changing with time. Discharge is a function of time. So you will say this is unsteady condition. This is unsteady condition. But beyond t equal to 20 second, the tap is fully open. So at t equal to 30 second also, the tap is fully open. So at t equal to 20 second, discharge was 1 liter per second. At t equal to 30 second, the discharge is 1 liter per second. So again, the discharge is not changing with time. So we have steady state condition. समझ रहे हैं आप? इस तरह से डिसाइड करते हैं स्टेडी स्टेट कैसे होती है. बट फॉर स्टेडी स्टेट यू फोकस ऑन वन पॉइंट. And what was the point? It was the outlet of the tap. You can take some other point also and you will get the same result. Inlet of the tap also you can take. ठीक है? चलो क्वेश्चन पे वापस चलते हैं. बाकी these things we will elaborate when the time will come. So it is saying, given that unsteady temperature field. So as soon as I read unsteady temperature field, immediately I will come to say field. Field means Eulerian approach. A Eulerian approach means temperature at a point when the time is t. But this is an unsteady temperature. This means temperature at the point is changing with the time. So temperature at the point is a function of time. है ना? So it says temperature is equal to xyz plus 3t. So temperature at xyz when the time is t. So temperature is a function of time. That's why it is unsteady. Now it says where t is in Kelvin, so this temperature is in Kelvin, and an unsteady velocity field. Velocity field, so velocity at a point when the time is t, but velocity is unsteady, so velocity is a function of time. So velocity at a point when time is t, so velocity is a function of time. है ना? So they are asking you what will be the rate of change of temperature of particle at point 2, minus 2, 1. है ना? What will be the rate of change of temperature of particle at point 2, minus 2, 1 at t equal to 2 seconds. So I think what they are asking you, they are asking you the rate of change of temperature of the particle. Which particle? The particle which is at the point x, y, z when time is t. है ना? So they are asking you dt by t, dt. Now check. How do we write temperature? So we are writing temperature as a function of position and time. So when I find out dt by dt, I think what I will say? I will say del t by del x del t by del x dx by dt, del t by del x dx by dt, plus del t by del y dy by dt, plus del t by del z dz by dt, plus del t by del time d time by dt. Check please, check please. Please check. So guys, check. This is Eulerian description. Temperature at a point when the time is t. So this is the rate of change of temperature at a point when the time is t. But the value at a point is the value of particle at the point. So this is the rate of change of temperature for particle at the point. ठीक है ना? And for particle, what is dx by dt? U. What is dy by dt? V. What is dz by dt? W. है ना? And dt and dt will cancel out. So what this will become? This will simply become dt by d time. Dt by d time is equal to dx by dt is u. So del t by del x plus dy by dt is v. So del t by del y plus dz by dt is w. So w del t by del z plus dt del t by del time. ठीक है ना? ठीक है? So this is how you find out. This is how you find out the rate of change of other property. ठीक है? Rate of change of other property. Now in the next class, this will be called as convective change, convective difference, and this will be called as local change. But अभी के लिए सिर्फ इतना ही solve करते हैं. तो क्या बन जाएगा? First of all, I need u. So I think the temperature function is given to me. Temperature function is given to me as x, y plus z plus 3t. So in this expression, I need del t by del x, del t by del y, del t by del z, del t by del time. So when I will say del t by del x, all other terms will become constant. So derivative of constant 0, derivative of constant 0, and y will be constant. So derivative of x is 1. So this will become y. Del t by del x will be equal to y. Similarly, I need del t by del y. X, z and time will be constant. So this will be x. Del t by del z. X, y and time will be constant. This will be 1. And del t by del time, this will be equal to 3. जल्दी से चेक करेंगे समझ आया या नहीं? जल्दी से चेक करेंगे समझ आया या नहीं? Please check. Please check. And velocity vector is given to me. How much is the velocity vector? Velocity vector is x, y, I cap plus z, j cap plus 5t k cap. So your u value is equal to xy, v value is equal to z, and w value is equal to 5t. So when I will write, बेटा जीरो कहां पे आ रहा है? Why written 0? हाँ, clear? Keshav check. Others, I hope I am going correctly. Now, how will you write the rate of change of temperature with the time? So, rate of change of temperature with the time is u del t by del x. So, u is xy and del t by del x is y. Plus v del t by del y, which is z. V is z into del t by del y, which is x. है ना? I think I should remove my video. And we have w del t by del z. So w is 5t and del t by del z, that is 1, plus del t by del time, which is 3. So this is the expression of what? Expression of the rate of change of temperature at point xyz when the time is t. So rate of change of temperature for the particle at xyz when the time is t. Now in our question we have a specific point. What is that specific point? I think that specific point is 2 comma minus 2 comma 1 when the time is t. So you will find out that value. So you will find out the value at 2 comma minus 1 comma 2 2 minus 2 comma 1 when the time is 2 seconds. So this will become x, which is 2, into minus 2 square, that will be 4, plus xz, that is 2 into 1, plus 5t, that is 5 into 2, plus 3. I think this will become 8 plus 2, that is 10, 10 plus 10, that is 20, 20 plus 3, 23. So what will be the units? Temperature is in Kelvin and time is in seconds. So 23 Kelvin plus per second. This is your answer. ये आपका आंसर है. This is your answer. Kindly check if this is clear or not. Kindly check if this is clear or not. Correct guys, correct. ठीक है. ओके, तो ठीक है फिर. तो ये क्वेश्चन नोट करो. सो एक्चुअली इट्स 3:30. सो मुझे अभी हमारी क्लास का टाइमिंग चेंज करवाना है. सो मोस्ट प्रोबेबली I will shift the timing of this class to 1:30 p.m. because at 3:30 the class of Tom and machine design starts. So I don't want to be a hindrance in those subjects. अगर कोई Tom पढ़ना चाहता है, मान लो कोई Tom और FM दोनों पढ़ना चाहता है, so I don't want to be a clash point. So आज के लिए आज यही बस करेंगे. But this will be a homework question. This will be a homework question. It is the same question which we have done now. And we will also discuss this question once. But just for purpose of understanding, I would like you to do this question as well. मैं चाहूंगा कि आप ये क्वेश्चन भी करें, सिर्फ अंडरस्टैंडिंग पॉइंट ऑफ व्यू के लिए. ठीक है. तो यहाँ पे मैंने कुछ ड्रॉ करने के लिए बोला है. यहाँ मैंने कुछ ड्रॉ करने के लिए बोला है. And in real life, actually this is a question of practical example. What you will draw is the flow of air in front of a billboard. होता है ना? When you go on GT road, so there is a good number of billboards over there. मतलब वो advertisement रहता है ना? So this is a billboard. This is a billboard. So there is the advertisement and Shah Rukh Khan is there. So when the air will strike the billboard, so air will show some peculiar flow, है ना? So when you will draw this figure, you will get the same flow. आपको सेम फ्लो मिलेगा. बस उसमें मैंने थोड़ा सा गड़बड़ किया हुआ है. गड़बड़ इन द सेंस वहां पे क्या होता है, वहां पे इस डायरेक्शन में भी फ्लो होता है. तो मैंने वो वाला फ्लो नहीं कंसिडर किया. मैंने सिर्फ इतना ही कंसिडर किया है कि इफ द एयर कम्स लाइक दिस, आइदर इट विल गो लाइक दिस और इट विल गो लाइक दिस. समझ रहे हैं? सो व्हेन यू विल ड्रॉ दिस, यू विल गेट द फ्लो इन फ्रंट ऑफ अ बिलबोर्ड. तो सर थर्मो, हाँ केशव, एक्चुअली थर्मो इज ऑल्सो गोइंग ऑन. थर्मो इज ऑल्सो गोइंग ऑन एंड थर्मो टाइमिंग्स ऑफ थर्मो आर 4 PM. तो वो इस तरह से बैलेंस किया गया है कि किसी भी टीचर की जो क्लास है वो क्लैश ना हो. तो अभी 3:30 PM पे दूसरा क्लास स्टार्ट हो जाता है, तो इसलिए मैं इसको बंद कर देता हूँ ताकि मैं उनकी क्लास में हिंड्रेंस ना बनूं. एक्चुअली उमा शंकर सर लेते हैं, MD की क्लास लेते हैं, मशीन डिजाइन की और टॉम की क्लास लेते हैं ऑन ऑल्टरनेट डे बेसिस, इसीलिए. बट दीज वीडियोज आर गेटिंग स्टोर्ड इन द प्ले लिस्ट. So if anyone is missing any lecture, he or she can access the playlist. So videos are getting stored in proper form. So I think the playlist name is Free Mechanical Course Gate 2020 Fluid Mechanics. Free Mechanical Course Gate 2020 Heat Transfer. ऐसा ही कुछ नाम है. तो आप उसको access कर सकते हैं. So those people who want to watch the other video, they can go. And if you have any doubts, you can ask doubts. अगर आप दूसरा वीडियो में जाना चाहते हैं तो आप वीडियो में जा सकते हैं. मैं देख के, जैसा कि पहले बच्चों ने बोला था, मैं टाइमिंग चेंज करवा दूंगा. बाकी लोग जो हैं वो कोई डाउट है तो पूछ सकते हैं. कोई भी डाउट है तो पूछ लीजिए. अदरवाइज वी विल रैप अप द क्लास. आदर्श, केशव, तो बेटा मैं आपको आगे का बता देता हूं, आगे का क्या अप्रोच रहेगा. एक्चुअली वी स्टार्टेड इन द बिगनिंग, and because the entire fluid mechanics is based on Eulerian approach, so I gave a slight idea what Eulerian Lagrangian approach is, and this will continue for a few days. At least 2-3 days more we will take in it. So we will practice some more questions. We will see the concept of discharge and mean flow velocity, how mean flow velocity is different than actual velocity. Matlab in the next class we will see local acceleration, convective acceleration, and we have to understand why local acceleration comes into picture, why convective acceleration comes into picture. ठीक है, तो ये आपका पूरा बन जाएगा local and ये आपका बन जाएगा Eulerian and Lagrangian approach. Now we are using Eulerian approach, and in Eulerian approach we write the terms as a function of point and time. So question is, what is a point? So definition of a point, it comes from concept of continuum. तो एक क्लास आपका छोटा सा टॉपिक है concept of continuum and Knudsen नंबर पे जाएगा, और एक बार वो काम हो गया then we will start with actual properties. तो आपके जो भी फ्रेंड्स हैं जो वीडियोस देखना चाहते हैं, आप उनके साथ ये वीडियोस शेयर कीजिए, और हमारी भी कोशिश रहेगी कि हमसे जितना हो पाए उतना अच्छे से हम पढ़ाएं. ठीक है. So thank you so much, and please do share and subscribe share the channel, subscribe the channel, and if you like the videos then spread the word among your friends. ठीक है. Thank you, bye bye.